factoring polynomials, and we have example 8 here. So we want to see if these have anything in common, and we notice that all of them have an x, and each one is also factorable by 4. So we can divide a 4x out. 4x to the 5th divided by 4x leaves us with x to the 4th. 4x cubed divided by 4x leaves us with a negative 10x squared, and 36x divided by 4x equals 9. Now we're still in the quadratic form because we have 3 terms. Last term's a constant, and our middle term, the degree of our middle term, is half that of our lead. So we can still factor this the same way that we would quadratic. So we have our binomial, and we have x squared and x squared, and then we want to figure out 2 numbers that multiply to positive 9 and add to negative 10. Normally we'd say 3 and 3, but 3 plus 3 is 6, so that's not going to work. So let's try 9 and 1. And in order to get them both to be positive, we have to multiply 2 negatives together, and then those will add together to negative 10. Now, again, we have difference of squares. So we can write down, we can keep our first one, and then we know what the square root of x squared is x, and the square root of 9 is 3. And then we have our conjugate pair, so we have a minus and a plus. And then we have a difference of squares again. So square root of x squared is x, and the square root of 1 is 1, and then we have our conjugate pair. And then for each one of these, we have to use the zero product property. So if I substitute 0 in for this one, I'll get 0 for the whole thing. If we substitute in a positive 3 here, a negative 3 here, a positive 1 here, or a negative 1 here, all these would be zeros. And so our answer will be x equals negative 3, negative 1, 0, 1, and 3.